the beginning of the chapter, we highlight the type of the G code and M code that we need to use, and then we go for linear profiling, circular profiling, and I told you these two parts are very important because when we especially for milling machines. So when we talk about milling machines, and the linear profiling is one of the most code that is used in the milling machine for G01, and then we talk about G02 and G03 for circular profiling. So you should go through the examples and the one that we highlight and practice it how we can use such G01, G02, and G03 to build the linear profiling and also the circular profiling for the CNC milling machines. Today we are going to go through programming whole operation, and even though we already talked about the drilling, when we talk about the whole operation means the drill. So we already highlight for the drill in chapter 4, but we are going to repeat again here, and we see some example to how we can use the code related to the cycle can drilling in order to create holes in the workpiece, and what's the difference between these different type of drilling operation. So usually there are some of the fixed or can cycle here. So these fixed or fixed or can cycle are designed or programmed to perform operation of drilling. So no need to go through the details of this can cycle. So because already there is one code already created, for example, or one address which is like GET, G81, G82, G83. So you are going to use this code directly into the G code that you develop, and this code will be used there to create the holes. So it's like complete or like a sub programs. We call it can cycle. So that means when you use this code, it will directly create holes, but in different way of or different type of holes. What we are going to do here, we are going to define only the coordinates or the place or location of hole on the workpiece. Then the spindle will move to that area or to that specific coordinates, and it will create a hole in that place. The size of this hole and the depth of this hole, also some of the parameters need to be defined, depends on the requirement for accomplish the task. Also, the place of the spindle will be, or the coordinate, the place of the spindle before and after creating such holes on the workpiece need to be defined clearly in the code. So the spindle will not affect the workpiece. Sometimes if the spindle go to the workpiece from the wrong space, or from either from the wrong coordinates, or the space between the workpiece and the spindle is not enough, or after create work or the holes, there is no clearance for the materials inside the holes. So all this will affect the quality of the produced holes on the workpiece. So there are some parameters need to be created, and usually this is the sequence for the program or for the programming of the whole operation here. Need to define also the program number and heading, setup for the job. Then we need to define the tools that we are going to use, because if you want to define, to create small hole or big hole, depends on the diameter of the tool that we are going to use. So need to define the tool here, and the tool length, the tool diameter need to be defined as well. So then we have to talk about the whole operation and how the whole will operate. Then if we want to change the tool to another tool, we need to stop the machine or the spindle, then change another tool, then use the another tool to perform the second operation or second whole operation. And this step will be repeated based on the requirement or the number of holes that we need to create. Okay. So one of the main drill cycle that we have, or drill can cycle here that we have, is GET, one, and the G81 here, when you use it, we need to define just the coordinate of the place. Then the spindle will go to the place and will stop at the R plane. It's like a reference plane here. First is go to initial start point, then you go to close to the Z plane, the place where you or where the machine will create the hole. This is the R plane. It's like on a specific distance from the surface of the workpiece. Then from this point, the spindle will go down to the workpiece. I mean, this is the initial condition or initial base. Then here like standby place. So the spindle here will be standby to create the drill. I mean to send the drill to the workpiece. Then create the first hole, then it go up again to the same workplace or to the same R plane here. So it will go and stop here for a while, then go for the next hole and create the next hole and go to the R plane again and then go to the next hole and so on. So I mean there are some parameters need to be defined in order to create multiple holes. But if you need to create only one hole, so it's much easier. But if you want to create multiple holes, so you need to define multiple coordinates for each point. There are also, we need to use G98 and also 99 for the Z position clearance. This after we finish or after the drill complete to finish the I mean to create the hole. So these two G code will be used for the positioning clearance to avoid any damage in the workpiece after finishing to create the hole. So the spindle will go up and stop at the R plane, waiting for or go for the before going to the next drill hole. Actually, you can apply this type of G code by using the simulator in order to see how the simulator will create the hole by using G81, by using G82, by using G83, and what is the difference. Each one, there is some parameter need to define. So when we talk about the G81 here, you need to define the X and Y, it's the coordinate for the place of the hole. You need to define the Z, which is the depth of the hole. For example, if the thickness of your workpiece is 20, so don't make the hole depth is 25, because at least, I mean, should be within the range or within the range of the thickness of this workpiece. So if you want to create hole here, you need to define what is the depth inside the workpiece. Is it 5 millimeter, 10 millimeter, 15 millimeter? It depends. So this one of the parameter you need to define. You need to define the R plane here. So R plane here for rapid point to start feeding. That means, as we said, it's in like standby position before the drill go inside the workpiece. Then when it's finished, create the hole, it will return back to the same point. Then we have the feed rate in inch or millimeter per minute as usual. So this is this one of the examples here for G code to create hole. And as you can see here, this is the point where we give the order to create the hole, which is G81. Then we use the G90 here for clearance, as we mentioned before. Then this is the depth of the hole, and here what is the R plane. Then what is the feed rate? After that, it will create the first hole, the second hole, the third hole, and the fourth. The first hole will be created on the position that is, or the who. This is the first position here, because the spindle will come to the first position first. Then when the start the cycle of create the first hole, it will create the first hole, then move to the second, the third, and the fourth holes. So as we can see here, these the parameters which is required when you write program for drill multiple holes in a workpiece. Other parameters here, as you can see here, any of these code, if you can refer for either for speed, for selecting the tools, for G90 here when you define your either absolute or incremental coordinates, okay, or you have to decide about the length compensation of the drill tool, or you will need to decide about the compensator of the drill itself, the size or the diameter of the drill. All these parameters need to be defined But when we talk about the drilling operation will start from the point when you position or locate the spindle on top of the first hole. Then when the cycle or the count cycle start here, it will create the first hole, then directly move to the second coordinate, the third coordinate, and the fourth coordinate. As you can see here, this is the position, for example, here, when we have x 1.5, y 1.5. So this is the axis of y here, and this is the 0.5. If this is the 0 point, I mean, or the 0 point, so we are talking about the y negative 1.5, because this is 1, this is 0.5, it is 1.5 in negative. Okay, so on the x-axis or on the right, because this is the 0 point, here all the value of x are positive. So we have here we have 0.5, we have 1.5, and here we have also 0.5, and here 1.5. But the difference between these two and these two holes in the y-axis, between these two holes and these two holes on the x-axis. So as you can see here, the coordinate is much important, but for the drill, no need to do anything. Just you write the code for drill or the drill cycle here or the CAD cycle for drilling, either the fixed cycle or other tab, which is the big cycle. Or I mean, it's not just one drill, one hole. Then sometimes there is spot drilling cycle, which is G82, and it's all about G81 here, the same, but with different coordinates. You can try this to create such workpiece with these dimensions, and then you try to create these drilling holes in the workpiece. The second type of drilling here, which is the G code 82, and 82 is more on spot drill. So here in spot drill, you have some of the parameter you need to define, but also in terms of the depth of the I mean the hole, in terms of the coordinates of the hole, all are the same with the G81. Okay, so here just to need usually such code, either G81 or G82, 81 or 82 or 83, all are modal code, I mean modal G code. So such modal code G code here will be activated, and all the coordinates after it will be execute the same G code. Also, we need in such code we need to define some if we have a dwell here, or like a constant time in second or in millisecond between each operation. I mean between one drill and the second drill. So or sometimes this drill will go inside, it will rotate for some time, then stop, then rotate again, stop, and so on. So this is there is usually the drill here is not depends on what is the depth of the hole. So sometimes if the depth is small, so just make like one spot in this place. But if you want the hole to be more deep, so in this case maybe the drill will not rotate only one time, it will rotate one time, then stop for a while, then rotate again, stop for a while, because this also will keep the tool or the head of the spindle here is safe, because when the drill is rotating for a long time, its temperature will go high due to the friction with the workpiece. So for that, they have different cycle of drilling. It's not all the same. It's not will be applicable for all materials. So it depends on the hole of the drill. I mean the depth of the hole, and also the type of the material of the work. This how to use the I mean what are the parameter which is required to use the G81. As you can see here, we have one more parameter which is B. This was not there in the G81, which is the dwell time at the Z depth. So I means we need to define some of the time for the spindle or for the drill to stop or to wait for a while, then it will return again to perform the task of drilling. As you can see here, this is the part which is involved for the G code for the, I mean, the drilling part, and all the previous one will either to make some comments, to define the program, the type of program, what type of the coordinates, what is the speed. Then we go for the length compensator of the, I mean, the length compensator and offset of the drill, then the depth or the standby position. Then we start to talk about the other parameter, which is more related to the drilling process. As I told you, you can create your own workpiece in the simulator, and you try to create different drill or different drill cycles. You use in the first one G81, then use G82 in the second position, use G83, for example, in the third task to see what is the difference in the operation of the workpiece or the spindle when it go to the workpiece, and how this spindle will create either the spot drill or the fixed drill, or also the third one, which we call it the big drill. So in the big drill here, which is G83, so there are more parameters need to be defined. As you can see here, we have Q, we have I, we have J, we have K, B, and so on. There are more parameters because these parameters actually are more involved when you want to create a big drill. Big drill, that means, as you can see here, it's not just create one hole. Because the hole is or the depth of the hole is very, or the hole is very deep, okay, so you need to create deeper hole here. So the operator of the spindle here will go in like stage one, stage two, stage three, stage four, and then it accomplishes the task for creating multiple, one single hole. So it's not like in the first, as you can see here, just you need to create one, like one spot. The drill will rotate, go down, then up. But in this case here, no. It's we call it big drill. So the drill here will create deeper. So like go for the first stage, then stop, then go down for a while, then go down until reach to the complete. And also this depends on the length of the drill here to create this hole. Same parameters need to be defined, but here we have more extra parameter, which is related to Q, which is related to R, which is related to I and J and K and so on. So you can see here, this is J, this is K, this is I, this is R. All this you can see here, the place here for I, for J, for these values of I and J are used to calculate what is the length of each stage, like in I1, I2, I3, and so on. I want you to focus on this type of the complete program. For examples, actually, either for linear profile, circular profile, or also whole operation here. As you can see, we have a complete figure and with the dimensions, and we need to create either for previously we talked about to create linear profiling or circular profiling, and here we are going to create a whole or to see how we can create a G code or a CNC program for whole operation. As you can see here, you have this is the workpiece, and the workpiece here with the predefined dimensions here, either for x-axis or for y-axis, and also for the thickness, which is the z-axis. And he gave you, he asked here to write a word address program for executing the whole operation. Focus in this example is more on the creating of the whole rather than the dimensions or the milling of the workpiece itself. Previously we talked how to focus on this milling operation to cut the workpiece based on the given information here. But now our focus will be more on the creating holes on this workpiece. So as you can see here, we have this is one hole, two holes, three holes, and four, five. We have four holes here need to be created, and the four holes they have different three with the same diameter and two with the same diameter. That means we need to use two type of tools. The first with the specific diameter for the first one. So this is the diameter is four for three holes, and here is the diameter is 6 for the hole number 7 and number 6. So as you can see here in this table we have the CNC tool and operation sheet. So the tooling here define the tool. So we have a drill, as we see before we have milling, but here we have drilling. So we already see how we can convert from between the drilling tool, between the milling tool, or also for the lading tools. So you need to select the suitable tool to the operation. So as you can see here, we have drill and drill. So the two tools are using for drill. So the first drill used to make 3 holes. The second drill will use to make 2 holes. The diameter here is 4, and the diameter here is 6.7. So in addition here, you have some of the setup notes. So this setup note says the part is held against the 3 pins by the 2 clamps, just to show you how the part here will be clamped to or fixed on the machine. Then set X0, Y0 at lower left hand corner. So lower left hand corner, that means this point. This is the part of origin or the point of origin. Okay. Z0 is the top of the part. That means if there is a thickness, that means this point will be 0 and the rest will be down. So that means the 0 point of Z will be on the top of the workpiece. So if I want to drill, I'm going to go in the negative direction. If the 0 is on the workpiece surface here or on the top of the surface, that means or if you want to drill, that means the Z value will be go in the negative direction. Here, from this figure, you can come out with some dimensions. Where is the place of circle number 4? What is the coordinates for circle number 3, coordinates for circle number 2, circles number 7, and so on. You can define the coordinate based on the given dimensions here for each center of values, and all in metric. That means all in millimeter here. The second you need to know is from the figure you can know how the machine starts and how the spindle is moved from which point to what point. So as you can see here, this is the start or reference point for the machine, start from 1, and this point 1 here is placed on the 115 and 460 here millimeter for in the x-axis and in the y-axis. So here, this is the first point, start from point 1, then go to point 2. That means the first hole will be created is the hole number at point number 2. Then it will create the hole number 3, then create the hole number 4. Then it's back to the tool change position. So this is the tool change position because we have 2 tools. We have 2 type of holes with different diameters. So the spindle will create number 4, then go up, and this is like place to rest and take change or change the tool. So at this point, the tool will be changed to tool number 2. Then it's go to the point number 6, which is the hole at point number 6. Then the hole at point number 7. Then it's go back to the point number 8, which is the same as reference point for point number 1. Okay, so that means from this figure here, you can get a lot of information which help you to write the program. And you should know what the structure of this program and what are the G code that you are going to use to create such simple or such simple program or to accomplish such simple task. So your task here to write the program. This program will be used to create 3 holes with a diameter of 4 here, and then another 2 holes with a different diameter, which is 6.7. So here are the complete program. So the complete program here with the definition here, what we have in the first part, what we have in the second part. So in the first part here, we have job setup data listing. So we in this just we have to write some of the comments or some of the information which is give or guide the operator what is this program is all about. It's just summary of the explanation here in this slide, for example. So we will mention the tools, and we need to create a holes and so on. So all this will be in the job setup data listing. So as you can see here, the program number, and here we have comment. So he said X0, Y0 is the lower left hand corner. That means define the reference point on the workpiece. Z0 is the top of the part. All this information already given in this. If you refer to this slide, you can find this information here. But how to translate this information into comments? So you need to write, to make this bracket, then you write the comment in between bracket here. So Z0 is the top, tool 1 is 4 millimeter, tool 2 is 6.7 millimeter. Both tools are drilled. So all this information just for setup. Then we start to machine startup sequence here to change for tool one here. So the first the machine need to use tool one, so need to define what is the coordinate in the beginning, then what is the units, is it metrics or in inch. Then we have to do the offset for the machines. Then we need to use for to cancel the compensator. As we can see previously, we have already mentioned how to compensate the diameter or the cutter diameter, and also later we have one simple example to see what is the difference between cutter diameter left, cutter diameter compensator to the left, compensator to the right, or cancel of the cutter compensator. Then we have a fixed cycle, which is G80 to be cancelled. Fixed cycle here, G80 is used to cancel the fixed cycle for the drill. Then go down. First, we need to return the machine or the spindle to the 0 point or to the reference point at this point, which is number 1. So this is just to send the machine to the reference point. So we can see here the G28, which used to have or to send the spindle to the reference point, and the coordinates here in incremental. Then we have x0, y0, z0. So this is the reference point for the machine, not the reference point for the part. As we said, we have reference point for the machine and we have reference point for the workpiece. Also, this you can see in the simulator. You can see the difference between the workpiece reference point and also the machine reference point. So you can make this one shift to 0, 0. So I means all become the 0, 0 at for the machine and for the workpiece. But usually they define different place, and they use the workpiece reference for the coordinates of the on the workpiece. But this one is just to go for the reference point for the machine. Then return to reference point here. After return to reference point, we can go for preset absolute 0 point. So here G92, X negative 460, and Y115. So according to this one, this is 460, but in the X-axis negative, and this is 115 is in the X-axis, in the Y-axis positive. So here you need to define like preset the absolute 0 point. That means you need to instead of 0, 0, 0, which is the original one here, so you need to define or preset it to negative 40, 60, 150, and Z0 according to the given information from the table. After that, we need to select that tool number 1 because we have 2 tools. So first we need to select the tool number 1 because the first operation will be done at hole number 2 here, at the point number 2. So this 2, 3, 4 all use the same tool, which is tool number 1. So just use tool number 1 M6 to change the tool to tool number 1. So tool 1 drill, this is the comment here. Tool 1 drill is for 3 holes, 4 millimeter diameter, and holes through. That means it will go through the all holes one by one. Then it will rapid move to point number 2 and start spindle clockwise at speed. This is the speed of the spindle. This is the coordinates for point number 2, and here we are using the absolute coordinates, and G0 means fast move or rapid move. That means it will move, the spindle will move to this place, but without conducting any operation or any task. It will be rotating and move to that point. After move to that point, then rapid movement to the tool number 1 for 2.5 millimeter, and this here Z2.5 H1 is like the standby position for the spindle to start the drilling operation. At this point here, we start to use the drilling. Actually, for this one, coolant on before. I mean, like this required for mechanical operation. When the drill is operate, you need to go to spray some liquid for coolant operation before the start to drill. Then start to perform the drill cycle, which is G83. When we talk about G83, that means we are talking about the deep holes, which require to define different parameters for either. In addition to the coordinate, you need to define the R plane, also the QO2 and also the feed rate as we see in this operation here for the big drill. The same here, the same as this operation. Then the feed rate is 60, so it will run at the feed rate 60. So this will be the first drill, then move to point number 3 to create the second drill, move to number 4 to create the fourth holes here, then stop the drilling cycle. G80 will be used to cancel the drilling cycle of G83 because we said it is a modal G code, and when we said modal G code, that means it will be activated until we cancel it by using another code, which is G80 in this case. After create the third the 3 holes, then it and the cancel the drill cycle, it will return to the movement or to the point of reference point or to the standby point at the level of 2.5 here. So rapid move to 2.5 above the part stop spindle. Then coolant will be off because we finished the drilling. So we need to switch off the coolant because we open it here. So here we just switch. That means this to cancel this operation here. After that, it will move to the first point. After reach to this number 4, spindle is off, go up to the level 2.5, then it will return to the point number 5 in order to change to the second tool. After we go for changing the second tool here, we'll move we change to the to the tool number 2, change to tool number 2. Then we have the comment here definition about the tool number 2. Then rapid move to point number 6 because after change the tool to number 2, the second position to create a hole is at the point number 6 here. Then after create the hole to go to point number 7. After create the hole, it will return to the reference point at point number 8, which is the same as point number 1. So start spindle here at clockwise with speed at 1800. It depends, actually this depends on the parameters. This parameter change according to this table. So the speed rate is or the speed is the beginning 2000 and the feed rate is 60. In the second tool is 1800 and the feed rate is 80. So actually in the beginning when we have the speed, it was 2200 and also the feed rate was defined to 60 here. But in this case, we have the speed is 1800 and also the speed rate or the feed rate would be changed to 80. Then we have the coolant on. Same here, we have the feed rate. This is the feed rate is 90. The definition of Q3, R2, Z, Y, X, all this related to the can cycle G83. It's required all this information. So here is the explanation for each code which is represented. Then it will perform the drill hole at X50 Y8 millimeter here for the hole number 7. Then the can cycle will be stopped or the can will be cancelled here. Then go move to the 2.5, which is the R place or standby place on the top of the workpiece or above to stop the spindle. Then coolant will be off, movement to reference number 8 and programming. So these are the steps actually need to be. I know you can create a similar program, but this is the like the optimum program or the ideal program to perform this task. Okay, so sometimes when you write a fast program, you just want to for testing, maybe you don't need to go for all these details. You need to, the most important, you need to define the coordinates and the place for each drill. You need to select your correct workpiece dimensions. You need to select your correct tool with the correct diameter, and you need to specify your parameters, which is like speed and feed rate and so on. So, but if you want to write a good program to be used with a real CNC machine, all these programs that we have in the slide are applicable to real CNC machine. Are not, it may not run on the simulators. any of the simulator may not run this G code, because the dimension of the machine in the simulator is different. The simulation, they have limitation in terms of the dimension of the machine, the size of the table of the machine, the size of the move or the dimension of movement for the spindle. I mean, limitation in the dimension of the spindle and so on. But this machine, I mean, this program will be there. I mean, it is applicable for a real CNC machine. If you want to create similar object by using the simulator, so you need to consider all this. For example, in the simulator, you cannot put it for 160 because you have limitation. For example, there is limitation for each machine. So if you go for milling machine, there is some limitation like 0 to 100. If you go for some of the turning machine, there is a limitation also, I mean, and so on. So sometimes if you go over the range of this, I mean, if the dimension of the workpiece is over the dimension of the table of the machine that you have in your simulator, it will not run, it will give you alarm. But what you need to do, you can adopt this figure or these drawings to suit with your machine dimension and also simulator. Okay, so in this case, you can, for example, deduct the size, divide by 2, divide by 5, times by 10, times by 100, and so on, to create a similar workpiece with a similar, I mean, overall similar shape here. Like one rectangular here at the end, before becoming rectangular, you go down with a specific angle here to complete the rectangular. Then you specify or define the dimensions or the centers of these holes to be created. Sometimes no need to go in detail. I mean, for simulator, it will help you to understand how the machine is work. So it will show you how the spindle is rotate, how the spindle will create the holes, how the spindle may be damaged, the place of the hole if there is no good clearance for the operation. If you do not make the correct coordinates for the spindle, it may be not go up enough from the workpiece, so it will affect the shape and so on. So it's just to emulate the real operation, but for to run such G code, you need to use either the simulator or the specific simulator that this G code was generated in, or to use the real CNC machines. This part for the G40 and G41 and 42, the cutter compensator, we already mentioned in chapter 4. So just here we need to, again, we go with one example here to show what's the difference between the three codes here. For G40, which is cutter compensator left, G42, cutter compensator right, G40, cancel cutter compensator, or either for 41 or G42. This one is 42, okay? So what's the difference here? For G40, that means we do not consider cancel cutter compensator. That means we do not consider the compensating the cutter size. That means when the place the cutter is existing, we are going to write the coordinates for that place, without considering how to replace this area or how to compensate such diameter. If you go to the right, that means you are going to place the cutter on the right, that it will affect the coordinates of the cutter place here to the right, here to the left. So also it will affect the dimension of the cutter to the left. As you can see here, also the same. Is it from outside or from inside? In both for G41 or for G42, from this is on the right, this is on the left, and here there is no consideration. As you can see from this example here, if you have this is the cutter, and this cutter with a diameter of 10, for example, I mean for the end milling D10, and the position here for the this point is the 0, point. So if this point is 0, that means based on the current and the x-axis here is the length is 50 and the y-axis is the length is 10. So if what is the position for this cutter here in the different cases, either for with that compensator, with the left compensator, or with right compensator. When we say with left compensator, I mean with that compensator, so the cutter here will move around either left or right, but we do not consider the difference in the distance here, which include the diameter. So as you can see here, the G40 x -5 y -5. Why x -5? Because this cutter here is placed on this area. So this area will be -5 in the x-axis because of the diameter here, and on the y-axis also because of the diameter negative here, -5. Then I mean, point actually it's more on the depends on the diameter of this place. Then it will go to next point, which is -5 and 15. So -5 and 15 here, it placed in this area. So if we assume this is -5 in x-axis and this is -5 in y-axis, so that means from -5 here to the top it will be 15, and because it will stop at this point, so +5, that means 10 plus 5, it will be 15 here. Okay, if we assume the diameter is 5, then we have if we go right also, it will go right the same at this point until reach to this point. So it will be like I mean to the border, it will be like the border here. So it will be like 50 plus 5, it will be 55. If we assume the diameter of this I mean of this cutter is 5 millimeter. Then go to this point also the same, it will go to this point here after this border. So it will be like -5 in the y-axis and x55 in the x-axis. So this is how in the case of the no compensator is there. But in the case we consider the left compensator, that means left compensator, the cutter will go on the left of this one. As we see here, for 41, is the cutter will be on the left of the real path or the original path. So in this case, if we consider that, I mean, we compensate the diameter of this cutter, which is 5, so it starts from 0, 0, because we do not count this the diameter of the cutter. The diameter of the cutter already compensated, so we start from 0, 0, go to here, which is 10 and 0, go to there, which is 50 and 10, then go to there, which is 50 and 0, and return back to 0 and 0. So this is in the case of the left cutter compensator. In the case of the right cutter compensator here, we are going to go on the right of the original path. So if we go if we are here, we are on the left of the original path, but to be on the right, so we should go in this direction. So on this direction will be on the right of the original path. That means the cutter will be on the right of this line. Okay, because this line will be on the left, the cutter will be in this area, all on the right. So in this case, we call it the G42 cutter compensator. We start from 0, 0. We ignore the value of, I mean, the diameter here. We compensate it. So go there on the right from 0, 0 until reach to the 50, 0. This is the first one, 50, 0 at this point. Then go up until 10, I mean 50, 10. So this is the point is 50, 10. Then go there until 0, 50. Sorry, 0, 10. This is 10 actually, not 50. Please correct this one. This is Y10 until this point, which is 0, 10. Then again to 0, 0, which is the original. So this is the differences between the two, I mean the two type or three type of compensator. The first is cancel compensator. So in the cancel compensator, we need to consider the diameter. If it's 10, we consider it as 10. If it's 5, we consider it at 5. Depends on the value here that we are going to include in the case of the cancel compensator. But we are going to use the real diameter, I mean the real coordinates, and these coordinates include the impact or the increment that caused by the diameter of the cutter materials. I mean the cutter tools. But in the case of compensator here, either left or right, in this case, we ignore the cutter diameter and we talk only about the original coordinates, but the direction or the path of the cutter here will be changed. Either in the case of the left, will go in this way. In the case of the right, will go to that. Another code, which is, we call it the circular pocket milling, and also the circular pocket milling, and here also the type of the tools or type of the cycles which create milling. I mean, like a bucket here, either circular bucket milling or normal bucket milling, either counterclockwise or I mean clockwise or counterclockwise. We have two, G12 for clockwise and G13 for counterclockwise. For this also to create a mail that with a circle, and we need to define all these coordinates, and you can see what each coordinate is means here from the definition for these coordinates. And here is one example for the circular pocket meaning. Okay,